Now we have a lot to work through in this video, but remember you can always download the final version of the Logisim file from the resources section and work through it at your leisure. Now at the end of the last video we looked at an 8-bit address decoder, but of course we've got a 16-bit machine now. So this is the 16-bit address decoder here, and I've already generated the memory map for this. So we're going to have 16 bits available to us on the address bus. So that means that we can address 2 to the power of 16 memory locations. So that gives us 65,536 separate memory locations that we can access. And remember, these memory locations now are going to be 16 bits wide, not 8 bits wide. The bottom of the memory is going to be taken up by the ROM, and then the next section will be the RAM, and then finally the I/O. The ROM is going to run from address 0000, so this is in hex, but in binary it would be 16 zeros, to a position 7FFF, so this is exactly 32,768 memory locations. Now the next one up is going to be the RAM, so it's going to go from location 8000 up to FFEF, and this is going to give us 32,752 memory locations that we can access in the RAM. So the ROM and the RAM take up almost all of our memory, but we leave a little bit at the top for the I/O, and it's going to give us 16 addressable spaces, and it's going to run from FFF0 to FFFF. So if we take these values here, our 32768, 32752 and our 16 is going to add up to the value of 65536. So this is our 65k of addressable memory space. So let's quickly just work through those values here in the simulation. So the ROM at the bottom has got a 0, so we'll start off at all zeros. Now if we work our way through and we add our values of 1 on all the way up, so we get to this point here. At this point here we're now at the top of the ROM, and that's at 7FFF. We then go on to the next one up, so that jumps up to the RAM. So the bottom of the RAM will be all zeros here. So that's going to be 8000, so that's the bottom of the RAM. Now we then head up to the top of the RAM. So when we jump in here it goes to the I/O, so we'll take that off and we'll add ones on here. So that's going to give us the top of the RAM, and it's going to be FFEF. And finally we go to the bottom of the I/O, which is FFF0 all the way up to the top of our memory, which is going to be a value of FFFF. So I've taken this here and generated an instance of it. An instance simply has the address coming in from the memory address register, and it splits it into these 3 options: an input, output, a RAM and a ROM. Now this is where things are going to change a bit. I'm going to go to the next level up, but you'll notice that there's been some changes made, so don't worry when we look at it and you don't recognise it. We will talk our way through it, and also it will be available to you in the resources section. So if I head back up to the next level up, it was originally called CPU_test, But I'm going to call it now CPU underscore motherboard. So that's the first change, it's just a change in the name. So you can see here that what we have is the CPU, and we have the input and outputs, and also the ROM and the RAM. So it's basically the CPU and the memory. So if you like, we can think about this as the motherboard. So in a motherboard, you're going to have your CPU, and you're going to have your maybe 4 RAM slots, and you're going to have slots as well for external RAM and other devices, so input-output devices. So basically it's just like a motherboard. Now there's going to be one level extra now, so we've taken all of the other outputs for the registers and we've taken it up to another level further up. So the next level up from this, I've generated another instance from this, and this top level is called the CPU user panel. So if you click on that, you can see we've got the top level. So this is our new top level. So our new top level's got our registers, our 0, 1, 2, 3, and our instruction address register, instruction register. It's got the 3 outputs here, and it's got 3 inputs. So these represent our input-output options. We've got our flags, we've got our reset conditions, reset ending our clock, and we've got our computer here. So in effect, this is a computer. This is the, if you like, the motherboard. Okay, so we've got our motherboard sitting here, and this is all just used in order for us to run simulations on this motherboard. Now let's drop down inside and we'll see the changes that have occurred in this. So the first thing we'll do is we'll get into the CPU. So at this level, the only thing here that we've changed is that we've taken the flags, and the flags originally were coming out as single pins. There were 5 of them, but what I've done is I've stuck them all into just a little bus. Okay, and we've called that the flag. So we're just taking it out a little bit neater. Now the other difference that we're going to see is going to be inside the control section, because we're not using the method that we found in the book in order to get information in and out of the computer, in and out of the CPU. So it means that the bottom one here of this 3x8 decoder is no longer used. So originally we had this in, and it generated the 4 extra commands for us, which were the data in and out and address in and out. But we're using memory mapped IO, so we no longer need any of that. So all of that has been ripped out. So you can go ahead, if you want, just rip all that out for anything that was hanging off of this little pin. Now there is another difference here in a naming convention, but we'll see the naming convention when we go up to the level further up. So if we head back into here, you'll see that the output here from the control section, we did have it was RAM enabled and RAM set. But we're not just writing to or reading from the RAM. We can write to some output ports, or we can read from some input ports, or we can read from the ROM. So I've renamed this CNTRL, E and S. So that's basically the control, enable and set. So this in effect is our start of our control bus. So our control bus has only got 2 values, which are set and enable. And these are going to come from the control section, but they're going to come from these points here. So originally this was just called RAM enabled, and there was another one over here called RAM set. They're now called control enable and control set, because they're not just for the RAM, they're for everything outside the computer. So that's the main difference at this level. Let's head back in and see if there's anything else. We call the bus line here, we've called that data bus in and the data bus out. So we can think about this here as the data bus. Now the address bus in effect starts here, because we take a copy whenever we're looking at an address and we put it into this memory address register, and it heads out in a separate pin, and this becomes our address bus. So that's the only differences really here that you see from the previous video. So let's go and we'll head up to this level here. So now that if we generate the CPU, you'll see it's changed a little bit, and I've adjusted it a little bit. So we're still going to have our clock coming in, we're going to have our reset coming in. The three values we take out from that level, which is the clock L, clock E and clock S, so we took those out into the top level. And we have our registers R0, 1, 2 and 3, which go at the top level. We have our end. So in our instruction register, instruction address register are flags, and we're going to have our output here from our three output devices. So that's our output device here, here and here. And we're also going to have inputs here from our input devices, which is going to be that one, and that one. So everything that comes from the CPU and goes to the outside world, okay, the top level, heads off to the left. And everything else here that gets fed or works its way around the motherboard goes off to the right. So you can see here that in effect what we have here are our address bus, which was our memory address register, but now we're calling it our address bus. We're going to have our control bus, which was originally our RAM set and enable, but we're just going to call it our control. So that goes together in our control bus. We're going to have the original bus, which is a bus in and a bus out, but we're going to call it that's going to be our data. So it's going to be our data bus out and our data bus in. Now the reason again we've got these two is that we want to get information in and out, but with Logisim we have to separate the input and output into different pins. So in a computer, in a motherboard, we're going to have the CPU and we're going to have these lines, and I've drawn the lines, and you see I've just drawn them going all the way around. So this is in effect equivalent to all of the buses running all the way around the motherboard. And then what you can do is whenever you have your components, you can connect your components onto the motherboard at the most convenient or the closest point. And that's what I've shown here. So we've basically got 4 lines that run all the way around in a circle. And then we're going to join all of their memory components on to those buses. So the memory components we've got, again, is our 32K ROM and our 32K RAM. And we've got our 3 input devices, we've got 3 output devices. We've also got our address decoder here. So let's have a little talk through this circuit and we'll see how it's connected up. So we know that our address decoder will tell us whether we are writing or reading from either the RAM, the ROM, or the input devices or the output devices. And this address decoder here, we've got our output for ROM, output for RAM, and then we've got another one here for I/O. The I/O I've just called that EN for enabled. And rather than running the wires all the way around the circuit, I've just generated the tunnels for these and connected them up with the tunnels. So if we talk our way through the ROM, because it's the simplest one, we're going to have a ROM which can only ever be enabled onto the bus. So we don't write into the ROM, it's read-only memory. We only read from the ROM. So all we have to be able to do is enable the information onto the ROM, from the ROM onto the bus at the right point. So it means that if we have an address coming in here and the address is in the correct position, that is, it's within the memory mapped position for the ROM, then this point here is going to go high and at this AND gate. But of course we're not going to enable anything onto the bus until the control line enable, which originally would have been the RAM enable, has gone high. So we have to connect onto this bus. So we connect onto the bus using these little connections here, so the splitters. So that's what all these little connections here are. They're splitters, allowing us to get into the bus and pull off the correct wire from the bus that we require. So in this instance here, it's only a 2-bit bus, so we've only got 2 outputs, a 0 and a 1. So the 0, 1 here is actually the enable. So whenever that enable goes high, it means we're going to have a high here, and we're going to pass this data from the ROM onto this bus. And you can see this bus, if you follow it round and down, it goes back into the data bus in, so it goes into the CPU. So we're taking information out of the ROM, down and into the CPU whenever the control bus tells us to enable that information, and also whenever the address is in the addressable position for the ROM. Now we do the same thing with the RAM for the enable. So the RAM enable comes along here, and we've got it going into this point here, and we have the enable being pulled off here, which is pin 0. And when these two go high, we're going to be reading information out of the RAM onto the bus, and that bus, it goes back into the CPU. But of course the RAM, we don't only just read from the RAM, we can also write to the RAM. So we've got to control the writing of information into the RAM, and we have to do that with the set. So it means that the control bus will come along here, and we're going to have our set. So our set's going to come off not pin 0 but pin 1. So it's going to get into the little clock set element here of the RAM, and the choice here of the set is going to come from the address decoder. So that address decoder will come in, and it's saying choose the RAM. Again, it's choosing the RAM, that case there, for the enable. We can choose the same point here for the set. Okay, so that's telling it, yeah, we're talking to the RAM, and then the enable, the set here, will tell us actually we know we're talking to the RAM, but this tells us we're going to write into the RAM. And of course we're going to have our address bus here as well, and we never talk through this. Address bus is here is for the ROM, so we'll have the address bus for the ROM and the RAM. But remember, we're going to have 16 bits here, but we're only actually going to be addressing a 2 to the power of 15 for the RAM, which is a 32K. So it's expecting to find a 15-bit value coming in. So that's why we've pulled this off, and we've separated this into 2 outputs. So there's one of them got 15 bits, and then the second one has got the 16th bit, which we aren't using. Okay, so we pull out those 15 bits, and that gives us 2 to the power of 15, which is a 32K. And again, we do the same thing here for the RAM, and we pull that out, and we pull out the 32 kilobits. So that's basically the ROM and the RAM, and it's just the same as we had seen in the previous videos, but we've just changed the diagram round a little bit, just to make it a bit neater. Now we do the same sort of thing here with our input-output devices, but we haven't talked through our input-output devices because those are going to change as well, because we no longer have our data in and out and our address in and out commands. So each of these has changed. So let's get in and we'll have a look and we'll see what changes we've made in these. So let's first of all drop into the input device. Now this is a bit simpler than the previous version. You can see here that we've still got our data coming in and we've got our bus out. Now the data coming in is the data that we would type in. So this is an input device like a keyboard. So we're typing information in at these points here. And this information will be getting passed out onto the bus and back into the CPU. And we've got a reset pin here. Now all we're going to be doing with this is writing data onto the bus. So we're reading data out of it onto the bus. We won't be writing into this device. So we can set the set pin to a high, and then all we're going to be doing is enabling this information through onto the output. So in effect it's like a transparent latch now, and it's controlled by this enable line. So what's going to ensure that we enable the information from this device onto the bus? Well, first of all, we have to know that this device has been chosen. That is, the address that's going out in the address bus is mapped such that it's telling us that it's mapped onto this device. So it's mapped onto this output device. So we're going to get the mapping of that memory block from an enable line. So this is from this enable line here. So this is going to come from our address decoder, and it's going to tell us it's a memory input output. So we've chosen a memory input output. Secondly, we have to choose which memory input output, because there's going to be 16 of them. And again, this is a neat little section here that was generated by Timothy Morgan. So thanks again, Timothy, because this is another brilliant little bit of circuitry. So what we can do is we can generate an input address. Now in this case here, we can call this device 0000. So we've got an option of 16, so we'll call this one all zeros. So whenever the input address actually goes all zeros, we've got this exclusive NOR gate, and that's going to give us only going to give us an input on all of these lines whenever all of these values here match all of these values. So if we had called the input device device 1, then this input address wouldn't be pointing to it, and it would be pointing to a different device. But it isn't, and at the moment we set that at 0, and let's say the input address is pointing to this device, so these all go high, and we're going to have a high here. Now the one other thing we're waiting for is the actual control line, which would have been from the load and store command. So it would be to enable the RAM, but it's now we just call it control enable. So we would just be controlling that here with this enable pin here. So whenever this goes high, it would pass this data onto the bus. Now let's see this at the top level, because it's a bit easier to understand at the top level. So if I drop into here, make it a bit smaller, so you can see, actually I'll make it bigger so you can see that bus and the data input. So this is it here. So this is the input device. You can see we can put our data in here at this point here. Okay, I'd have to go simulate, reset. I'll put the reset high and low. Okay, so we can put our information in at this point here, and you can see we've got a reset pin here. We're going to have the address bus here, so we're going to take only the 4 connections from the address bus that we require. Okay, so that's going to be from 0 to 3, and this is going to come in here, and it's going to tell us which device we're actually trying to address. Okay, and we've got the ID here. So the ID for this device is a value of 0. So we've just generated this little bus here, and we've got them all sitting at a value of 0. So if we click on this here, click on that, you'll see that we've got this here, which is a constant, and it's a 4-bit constant, and I've just made them all zeros. So this is device 0. Whenever we're trying to poll or talk to device 0, it will come down here. So when this is equal to this, we're going to have one of the enable lines options is going to go high. Now the other one's going to come, as I said, from the IO. So the IO enable is going to come from here. And finally, we're going to have it coming from the clock enable, which comes from the control line. And I've connected into the control line down here. Okay, so this is just this control line that runs all the way around. And then we're going to have our data out, which will come along and go back into the bus input. Now it's very similar with the output device, but with the output device, we're not reading from it back into the CPU, we're actually writing into it. So it's like a monitor, and the information's coming out of the CPU into the monitor. So when we drop inside and have a look at it, you'll see that it's almost exactly the same, but the only difference is that instead of this being a control enable, it's going to be the control set, because we're going to be setting information in. That is, we're going to be writing information into it using the set port. So we're going to be connecting into the set here and not the enable. And the enable here can just be set to a value of 1. So it just becomes, again, a transparent latch whenever this point here goes high. But this isn't going to go high unless these 3 lines have gone high. And again, we're going to have we're going to have to have this enable here go high. So this is again coming from the address decoder, which is telling us that we're in the IO block of addresses in the memory. And also we're going to have the ID. So in this case here, the ID for this one is value 3. So whenever the address register, the last 4 bits go to value 0011, we're going to get a high here, telling us that we're actually choosing this device. And finally, we're going to have the control line, which is going to control the set and the enable. So this is, again, it's like the RAM set and RAM enable commands from the load and store. So this is coming directly from the control unit output, and this is going to be the set one. So the previous one for the input was the control enable, and this is going to be the control set. So when all of these go high, this here becomes a transparent latch, okay? And it means that the data that it comes in here is going to be held within the actual memory here. So whenever any of these go low, you'll see that this information is now retained in this device. So this has been a very long video, and we're just about done now. So if we just generate a little bit of code, not a large bit, but we'll do something really small just to get us started. So we're going to have to, first of all, reset the device. So if we click on this level, you can see that's us reset the device. Once it's reset, we're going to have to make sure that the ROM has information in it. Now, the only information the ROM's going to have in at the moment is where is the program held. So it's going to tell you where to go to get the program. So the ROM is going to be just a jump command. So the jump command is 0040, and it's going to tell you to jump to address 8000. So whenever we get to this point, it'll jump to that address. Now, where's it going to find that address? It's going to find that address in the RAM, because that's the start of the RAM. So you could put a program in the RAM. So for example, 0020, which is just a data command, and you could put in, say, 000F, So, and then we could finish it off 00CF. So all this does is it's going to take the value 000F and put it into one of the registers. I think it's register R0. So let's run through the actual simulation and we'll see that actually doing that. So you go to the control panel and we'll actually just run through, go simulate and tick enabled. And you can see here that it's gone through and it's put the value of 000F into register R0. So that's exactly what we would want it to do. Now, we're going to be extending it on this, okay, and we'll be now looking at the control unit. We want to simplify the control unit a bit. But I'm also going to have to update the assembler debugger for the 16-bit machine. And that's something I'm going to be working on over the next few days, and I'll get that up and running for us. So that's enough for this video. It's been a monster. I'll get you in the next video. Goodbye.